Hi everyone, I'm Cheryl. In this example, we're going to be finding the principal unit normal vector of my vector function ti plus 1/2 t squared j when t equals 2. Now, in order to find the principal unit normal vector, we have to take t prime of t divided by the norm. Now remember what t prime is, it's the tangent vector. So we have a lot of things we have to calculate before we're ready to plug it into our formula. So let's take this one step at a time. Let's first of all find the tangent vector. So to do this, I'm going to find r prime of t, which is just I, plus tj. And then I have to divide that by the norm of that vector. So that's going to be the square root of 1 plus t squared. So I can write this as 1 over the square root of 1 plus t squared times vector I plus tj. Okay, now I need to find the derivative of that vector function. So to find the derivative, I'm going to be using the product rule. So I have a function in terms of t times a vector function. So again, the product rule tells me I'll take the first piece, which is 1 over the square root of 1 plus t squared times the derivative of this vector function, which is going to be 0 plus j. So that's just my vector j. Then I'm going to add I plus tj times the derivative with respect to time of that function. So that's going to be a negative 1/2 times 1 plus t squared to the negative 3/2 times 2t. Okay, I can do some simplifying here, and I'm going to end up with 1 over the square root of 1 plus t squared times my vector j. And here, this 2 will cancel with this one, and I'll end up with I plus tj times a minus t all over 1 plus t squared to the 3/2 power. Okay, I can even rearrange this a little bit so that I can group my j terms together and my I terms together. So I'll have a minus t all over 1 plus t squared to the 3/2 times my vector I plus 1 over, I'm going to write this as 1 plus t squared to the 1/2 power minus t squared all over 1 plus t squared to the 3/2 power times my vector j. Okay, let's see if I can do a little bit more simplifying here. I'm going to come up here and I'll have my minus t all over 1 plus t squared to the 3/2 times vector I, and I'll have plus, I'll get a common denominator of 1 plus t squared to the 3/2 power, and I'll write this as 1 plus t squared minus t squared, and that's times my vector j. So I have minus t all over 1 plus t squared to the 3/2 power times vector I plus 1 all over 1 plus t squared to the 3/2 power times my vector j. Okay, and that gives me the derivative of my tangent vector. All right, now what do I need? For my unit normal, I need this vector that I have divided by its norm. So let's put this down here, and I will have a minus t all over 1 plus t squared to the 3/2 I plus 1 over 1 plus t squared to the 3/2 times j all over the norm of that function. Now, remember what that is. We've got to take the square root of the square of each of those components and add them together. So if I square this first component, I'm going to end up with t squared all over 1 plus t squared quantity cubed. And then when I add this component squared, I have 1 all over 1 plus t squared quantity cubed again. Okay. I now keeping working with this, I'm going to have a minus t all over 1 plus t squared to the 3/2 I plus 1 over 1 plus t squared to the 3/2 times vector j all over. Now, when I get a common denominator here, notice my common denominator is 1 plus t squared to the 3rd power. They have the same denominator, so I can just add the numerators, and I have t squared plus 1. And what happens there is I end up with t squared plus 1 over 1 plus t squared quantity cubed. That reduces to 1 over 1 plus t squared squared. And this also reduces because I can take the square root and I end up with 1 over the quantity 1 plus t squared. Now, when that happens, I can do an invert and multiply. And when I finish, I end up with minus t all over 1 plus t squared to the 1/2 power times vector I plus 1 all over 1 plus t squared to the 1/2 power times my vector j. All right, that is my unit normal vector at any point. I'm interested in what's happening at t equals 2. So what happens when t equals 2? Well, my normal vector then becomes a minus 2 all over the square root of 5 times vector I plus 1 all over the square root of 5 times my vector j. And that is my unit normal vector when t equals 2. I hope that was helpful. Thanks.